This video is about complex problems. In particular, what are problems and why are some problems considered complex? So if you are a researcher, perhaps a professional or anyone who is looking at addressing a problem, a societal problem, say, or you're researching a sort of phenomenon, or a certain topic, and you don't know how to start, how to think about the problem and its complexity, then this video would really be useful for you. So let's start with, what does a problem mean within the context of this video? A problem is considered a dilemma that can't be solved using existing current worldviews or existing ways of thinking, if you like. There are two distinct parts to problems: problem complexity and also the diversity of views of people. And let's talk about each one of them. So let's talk about the first thing to consider when we look at and try to understand problems: its complexity. Problems can be classified as simple, complicated, or complex. So why does this classification of problem situations to simple, complicated, or complex matters? It matters because it relies on the number and type of components of the problem situation that you're trying to look at. It relies on the characteristics of the problem situation. It relies on the interaction between the number and type of components and the characteristics of the problem situation. It refers to how problems are defined, described, and structured. And also it refers to how unpredictable the problem situation is likely to be. So that's why this classification of problems into simple, complicated, and complex is really, it does matter, and it's very important to consider. Let's take an example to explain these differences of how we classify problems, to just give you an idea. On the left-hand side, you could see that there is a simple wooden chair. The design of this chair can be classified as a simple problem, because a chair consists of parts, and we could put these parts together, which by now we know how to do, because it's really straightforward. You've got different wooden parts, maybe other types of material. You know by now how to make a chair. You just put them together. You have a design in mind, and voila, you've got, a simple chair to sit on. So this is a simple problem. In the middle, you could see a bus, your typical London bus. The design of this bus would have consisted of thousands of mechanical and technical parts, and it is therefore considered complicated. So we could classify the problem of building or designing a public bus as complicated. Yes, you have many mechanical, perhaps technical parts, even electrical parts that you need to incorporate together. But by now, I think we have figured out how to put a functional bus together. And this is considered a complicated problem. If we compare it to the chair on the left-hand side, it might consist of more parts, and it might involve maybe more people that would design to consider, but it is still not a complex problem, because we know how to do them by now. Both of these problems are not complex by any means, because they describe, structure, and present relatively simple and predictable behaviors. Now, let's take a look at what we have on the right-hand side of the slide. If we want to design a transportation system, then this will be considered a complex problem, because it follows unpredictable rules in that it has a different nature of components and characteristics, as well as a number of interactions between different parts. Like, for example, depending on what you want to incorporate and build for, your public transportation system, say take a new regional place, a new regional council, a regional area in a country. You want maybe to incorporate a train system. Maybe you want to add cycling lanes and a cycling system. Maybe you want to have light rail, ferries, and so on. So you could see why this problem is considered complex compared to designing and building a bus as well as a chair. So we talked about problem complexity as one of the two distinct parts of problems. Let's now talk about the second part, which is diversity of views of people. A problem situation can lead to a diversity of views because of the multiple values and interests of those involved and affected stakeholders or people, which lead to different goals, expectations, and also worries about the problem situation that you're trying to address. Diversity can also come from and this is important to keep in mind, from the differences in social relations in relation to power, domination, and also even alienation of people. This exists between individuals and groups in different hierarchical, economic, and political positions. So if you go back to the problems that we have, that we talked about just before, designing a public transport would involve a diverse number of stakeholders compared to designing a bus or designing a chair. That could be more easily and more maybe perhaps straightforward compared to designing a public transport. And that problem is considered complex because it will involve a diversity of views of different stakeholders, of different power relations, domination and alienation, different goals, different values, and so on. So hopefully this video gave you an idea of an appreciation even of problems if you're trying to address them, and in particular how to think, and what to consider in relation to complex problems, what problems are. And the key reference for this video was from Costa Jr. and colleagues, from a publication from 2019 called A Framework for a Systems Design Approach to Complex Societal Problems.